Yes. Good morning, colleagues. That is Tala, Alfred, Christian, Musa, and Lawrence. Good afternoon. It has been a while without us having a bit of brainstorming session or knowledge sharing session. But I know you guys are busy. You're also reading, because that has been our theme, and the motto is reading, reading, and reading. You have to read. By the time you go back to university, I think you should be somewhere. You should have something on bridges and structures. I think a few days ago I posted something on the wind effect on steel canopy or canopies. Then later on I followed with a post on how to be mindful of the two key connectivities. That is the base plate area, column base connection, and also column roof connection. I indicated, unfortunately, Midas Civil does not do connection design, but I've been made aware that there's a Midas Civil Plus or something that can handle. I think this would be introduced to that by the Midas IT India. So that means you need another software for you to be able to do the connection design, like Idea Statica. I don't have a license for that, and also the robot structure. I think that one we do have, can design all these connections, but I think we are more concentrating on the Midas capability and how user-friendly it is to help you engineers try to accelerate and accurately do what you do in the bridges structure as well. So now, basically, I just want to demonstrate on the design. Once you are done with model, now you have done with analysis, everything you have done with, you go to the stage of designing now sections so that you are able to specify it. That's now the final output that goes to your AutoCAD people, detailers, and then the quantification team. So we have the design, and the design basically you are trying to work within the employer's project cost and time constraints. So always, whatever we do, I know for structure, safety is first, then cost. Normally you have to weigh cost and come back to safety, and then vice versa. So it is very important. So in this case, you need to be mindful. So we shall do design, and somewhere to some extent you also do cost of design optimization, so that you look at, now we have made specification of all this section, but if you do optimization, you will find that it is not actually, you need another section which is slightly smaller but safe, durable. So you come to the design section, you go to steel design, and there are all these requirements that you need to fulfill to be able to get the output. So the first thing is to define the design code. We have quite a number here: Ashito, your LRFD1, now 17, then 16, 12, all the way to Eurocode 3, then BS 5950, Part 990, then IS 800, IRC, CSA, all that you can choose, the one that you are going to do, and then you do the design. For our case, we are dealing with Eurocode. Then this other requirement you can also indicate, they're all indicated here. Checking beam and column deflection, maximum moment along the member, all this you check. Then after you have done, then you go back to the next command, is the strain reduction factor. I think these are given, but with our readings and being accurate, basing on what we are designing, you should be able to look at it and modify accordingly. In this case, we are leaving it as default. Modify still. Now, always you come and modify here. That means the tensile strength, all that have to be done. But in this case, it's all has been all filled. Then you come down to serviceability parameters. This is now where serviceability basically crack and deflection, deformation, crack, and other things. So looking at this steel, we don't have anything to do with concrete, so it means we don't have anything to do with crack check. So I think in this case, for deflection control for beams, we can do a L over 250, but we shall read more and then get to know which one is applicable, depending on what you have model. And then for column, let's also adopt H over 300, but I think I give you a task of reading. I will also do mine so that we are able to know for the column what could be the requirement, why H over 150, what are the limitations, why H over 300, what are the limitations, and the user. For user means now if you read more and then you depending on site specific, you should be able to specify that. So in this case now we have that. We are able to put that in place. So we continue, we go now to serviceability load combination. In the first submission, you saw something to do with Q, with the FH, with CH. Those are characteristic loading. Then you have the frequent loading. Then you have the quasi-permanent, which are associated with serviceability limit state when you are dealing with Eurocode norms. So basically now with this, it has even guided you where do you place when it is a quasi. Quasi is related to more of permanent work, permanent loads. Then the rest have got the life loads, and then which are leading variables and those which are not leading variables. So basically these are things that when we read more, we are going to do that. We shall look at loading in detail and get to familiarize ourselves with that. Then I think this is the most critical one, is that serviceability limit, and then this transverse stiffener, if it is a girder, beam girder for bridges where it requires stiffeners and the rest of it, you should be able to specify. Then the steel design table, this one have we already done. The bending coefficient, basically these are all, we can look at it in detail. You should be able to look at it here. They have given us as 1, but we need to also calculate by program. If you say calculate by program, then it should be able to do that. So we can leave it as per the default value. And then when you come down now, the design is first we are going to do code checks. So we will design according to the code. So each requirement related to the steel will be checked accordingly, and you get to know all that. So you can go to the steel code check now. This okay, now you can see, as you can see now, your column has failed and then other members have passed. I think if you look at by member, now you can see so many members. Everywhere it is column component, because you see this column has so many, how many component of this, the division. So that's why you are seeing all this line here. That's the division of the column. So this is for column 1, and this is for column 2. So all this division is indicating red. So, but if you go back in terms of properties, it's only showing you that column has failed. So now this is where you can quickly look at this, and then you go and look at your graphics, and then you view your column. You look at column, it has failed by deflection. So now you can see. Now you can go back, you should improve on stiffness and other things. So the rest, the beams and these other members are all passing the requirement as set by the code. So once you have this, then you are able now to do what? You are able to print out this report and share with your detailer. So we can save this, and then basically this is the steel design. I think we can save that. So we can move to, now once you have done design, you can now move to optimization. If you want to have a look at optimization, now you see that actually there is some saving. So let it do optimization and we check that. So for optimization, we can do analysis option. I've given it repetition as 1, and then I do my design and analysis. Let it do that. Good. So once that, okay, section has not changed, so there could be some errors. That one, don't worry, so I don't know that. So we can look at the text report model. So I think here we can go to text report. We can petrol. I think that one is I can put 3, and then I save. So here is what you have. We have let me open it from it has saved it on our where we are saving all our document lecture, and then petrol is here, and then this is 3. Oh, what is this? Is it this one? Petrol station, petrol 2. Oh my god, why is it not appearing still? Text petrol. Okay, it's not why is it behaving? Petrol station public. Oh, cannot. I think I have a problem with my. So here basically, so okay, let me quickly show you. Okay, it's a bit not very clear, but if you look carefully, we have two areas. There's the original section, and then you have the optimized section. If you look at these sections are all different. So this is 305 by 102, while the other one is 305 by 305. No, 305 by 102. So I think it has not changed. I don't know why. But if you look at the tonnage here, it's 45. So they did. Oh, I now recall that I think when I was doing the thing, I did it and I did not. It had already optimized. The original one was actually 60.7 tons. It moved to this 40 something, and the section was 305 by 306, which moved to 305 by 102. So now that is what is happening. It had already been updated. I did the update, which has already made that changes. So we are not able to see the you see. I think there was somewhere analysis option. Yeah, it is actually here. This one all already been modified accordingly. So if I had not finalized that with updating the model, then I was supposed to see the, you see how it was here from the model update. So I click this model update, and then analysis result is deleted. Do you wish to continue? So that's how it moves that way. So I think that this is exactly what you do when you are dealing with the design. So I think if you try to follow with some example you have, this is where you end and you get the output. This output is what you share with your designers, and then those who are in the quantities office. That is how you can do it. Then thank you so much. This ends our steel canopy. The next episode will be now more on bridges. Let's now concentrate on bridges, reinforced concrete, precasts, and then we can move to post-tensioning of the similar construction.